A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. You ever have that dream where you're trying to clean a house, but every time you move a chair, 3 other people move it back to where it was, or maybe into the kitchen? That is basically what it feels like to run 3 instances of Claude Code on the same repository without a plan. It's pure, unadulterated chaos.
It's the digital equivalent of too many cooks in the kitchen, except the cooks move at the speed of light and they don't actually talk to each other. They just assume the stove is theirs. I'm Herman Poppleberry, by the way, and today we are diving into a prompt from Daniel that hits right at the intersection of old school version control and the absolute bleeding edge of agentic workflows.
Yeah, Daniel sent us a great one here. He's asking about how Git is flexing and failing to handle these new agentic development patterns. He wants us to imagine 3 AI agents working simultaneously on one codebase. Do they need to talk to each other? Why does it end in disaster when you run parallel sessions without an orchestrator? We're looking at regressions, lost work, and the forgotten commit syndrome.
It's a fascinating tension because Git was built for us, for humans. It assumes a certain level of intentionality and, frankly, a human scale speed of operation. When you inject agents into that system, the primitives start to creak. By the way, quick shout out to our sponsor. Today's episode is powered by Google Gemini 3 Flash. It's writing our script as we speak.
Which is fitting, considering we're talking about agents taking over the keyboard. So, Herman, let's set the stage. It's April 2026. According to the latest GitHub Octoverse data, 12% of all commits are now fully authored by autonomous agents. That is a massive jump from even a year ago. We aren't just using copilots anymore, we're using crews. But Git is still, well, Git.
Git is the bedrock, but it's a bedrock designed for sequential, thoughtful branch merge, push cycles. The core issue is that Git assumes a single index or staging area per working directory. If you have agent A and agent B both trying to use the same working directory, they are going to trip over each other immediately.
It's not just tripping, it's a full-on collision. If agent A starts a refactor in a file and agent B decides to run a git checkout to see a different branch, agent A's uncommitted work is just, poof, gone. And we've seen this in the Claude Code issue trackers, issue 29. 110 is a classic example where worktree cleanup or unexpected crashes just obliterate hours of thought and token spend.
That uncommitted work, failure mode, is the silent killer of agentic productivity. Humans generally have a sense of, I am in the middle of something, so we don't usually run destructive commands while we have dirty files. But an agent might see a terminal error, decide the best way to fix it is to reset to head, and suddenly it has deleted the very code it was supposed to be iterating on.
But wait, how does that actually play out in a real CLI session? Like, if I'm running Claude Code and I tell it to fix a bug, it's basically just running shell commands, right?
It's executing cdoduc or techo or writing directly to the file system. If you have a second agent in that same folder, it might run a tget status_c, a bunch of modified files it doesn't recognize, and, being a helpful agent, think, oh, these shouldn't be here, and run a tget checkout.d to clean up. It's trying to be helpful, but it just lobotomized its partner.
It's like the agent has no short-term memory of its own physical state. It relies on the file system to tell it what's happening, but then it uses tools that mutate that file system. So, if we can't just throw 3 agents into one folder, what's the move? Daniel mentioned Git worktrees. I know you've been obsessed with these lately.
I have, because worktrees are the forgotten Git feature that was basically a prophecy for the agentic age. Introduced way back in Git 2.5, which was 2015, worktrees allow you to have multiple working directories attached to a single local repository.
So instead of git clone 3 times, which wastes space and keeps 3 separate versions of history, you just have one det folder and 3 different folders with the actual code?
Precisely. You can have a trees directory, and inside you have agent 1, agent 2, and agent 3. Each one is checked out to its own branch. This solves the dirty directory problem. Agent A can't accidentally delete Agent B's work because they are physically in different folders.
Okay, so that's the isolation layer. Problem solved, right? We just give every agent its own room and tell them to stay there until dinner is ready.
Not quite. And this is where it gets really interesting. Isolation is not coordination. Just because they are in different folders doesn't mean they aren't working on the same logical project. If Agent A completes a massive refactor of your authentication logic and merges it into main, Agent B is still over in its work tree, happily writing code against the old auth logic.
Right, so Agent B is basically hallucinating a reality that no longer exists. It's like 2 people writing chapters for a book, but one person decides the protagonist is now a cat, and the other person is still writing about a human. The chapters merge. Technically, the text doesn't overlap, but the story is broken.
That is the logical merge conflict. Git is great at saying, hey, you both edited line 42. It is terrible at saying, hey, you both edited the same conceptual dependency. And when agents work at compute speed, meaning they can crank out 500 lines of code in 30 seconds, the window for these logical desinks is massive.
But couldn't you just tell the agents to pull the latest changes every time they start a new subtask? Like a heartbeat pull?
You could, but then you hit the rebase hell problem. If Agent B is in the middle of a complex multi-file change and Agent A merges a breaking change into main, Agent B now has to stop, rebase, resolve conflicts, which it might not be great at, and then resume. If this happens every 2 minutes, Agent B never actually finishes its task. It's just stuck in a loop of updating its environment.
So if the file system isn't enough, what is? Do the agents need to be on a Slack channel together? Hey, Agent B, I'm touching the database schema. Stay out of my way?
In a way, yes. We are seeing the rise of what people are calling protocol-level coordination. Instead of just relying on Git to catch mistakes after the fact, the harness, the tool like Claude Code or a custom orchestrator needs to manage the state of the agents.
Daniel brought up file level locking. That sounds very 1990s version control, like SVN or Perforce. Are we really going back to checking out files so nobody else can touch them?
It sounds regressive, but for agents, it's actually a superpower. Think about it. An agent doesn't have ego. It doesn't mind waiting. If an orchestrator says Agent A is currently rewriting ap.teds, you have a lock. Wait for 5 minutes. The agent just pauses its token generation. It saves money and prevents a collision.
I love the idea of agent sync or lock servers. There's a company called Authra doing this with something called preemptive locking. Before the agent even opens the file to read it, it has to claim a token from a centralized server. If the lock is held, the agent pivots to a different task or waits.
And these locks have a time to live, or TTL. That's crucial because agents crash. If Agent A's subprocess hits a rate limit or a recursion error and dies, you don't want the file locked forever. The lock expires, and Agent B can take over.
It's funny how we're reinventing database concurrency patterns for text files. But let's talk about the discipline versus protocol debate. Some people argue we don't need fancy lock servers, we just need better system prompts. Dear agent, please check if main is updated before you finish your task. Does that actually work?
Not at scale. Discipline is for humans because humans are slow and can be shamed. Agents are fast and have zero shame. If you tell an agent to be careful, it will say, I will be careful, and then it will immediately overwrite your config file because it prioritized the immediate instruction over the vague guideline.
True. I've never met an agent that didn't think its current task was the most important thing in the universe. So, we need the harness to be the adult in the room. If we look at Claude Code specifically, it's already moving toward this orchestrator model.
Right. We're seeing features like orchestrator mode, where one boss model breaks down a huge ticket into subtasks and dispatches them to worker models. The boss model is the one managing the Git state. It's the one saying, okay, worker 1, you get a work tree for the front end. Worker 2, you get a work tree for the back end. I will handle the merge.
That feels like the orchestrator worker pattern we've discussed before. But even then, the merge is the scary part. If I have 5 agents all submitting pull requests at the same time, my CI/CD pipeline is going to explode.
That is a very real bottleneck. Imagine your Jenkins or GitHub Actions bill when 5 agents are each triggering a full test suite every 10 minutes. You'd go bankrupt in a week.
So what's the fix? Do we need agent only? CI?
We're starting to see incremental CI. Instead of running the whole world, the harness identifies exactly which files changed and only runs the relevant unit tests in a pre-flight check before the agent is even allowed to propose a merge. It's about shifting the validation left, right into the agent's loop.
That makes sense. And that's where merge queues come in. You know how big teams at places like Shopify or GitHub use merge queues to prevent main from breaking? Instead of merging a PR directly, the PR goes into a queue. The system merges it into a temporary branch, runs the tests, and if it passes, then it moves to main.
And if it fails, it gets kicked out of the queue automatically. For agents, this is mandatory. You can't have a human reviewing every agent PR if they are producing them every 2 minutes. You need an automated gatekeeper that uses Git primitives like rebase and merge, noff, to ensure the history stays clean and the build stays green.
I'm curious about the benchy pattern Daniel mentioned, using parallel agents to implement the same feature 3 different ways in 3 different worktrees, and then having a judge agent pick the winner. That is pure compute flexing.
It's the ultimate brute force engineering. I don't know the best way to optimize this SQL query, so I'll hire 3 agents to try 3 different indexing strategies in 3 separate worktrees, run a benchmark in each, and the one with the lowest latency wins.
That is wild. It's like evolution on fast forward. But how does the judge agent actually decide? Does it just look at the code, or does it look at the telemetry from the worktree?
It has to look at the telemetry. This is where the harness needs to be, obs aware, observability aware. The judge agent pulls the execution time from the benchmark logs in each worktree, compares the memory overhead, and then, this is the cool part, it deletes the 2 losing worktrees and merges the winner.
It's a literal survival of the fittest for code snippets. But again, you need that isolation. You can't run 3 benchmarks on the same machine on the same port. You need the harness to manage ports, databases, and file system state.
And that's why I think the harness is actually becoming more important than the model. Anyone can call an API, but building a harness that can manage 3 parallel Git worktrees, 3 ephemeral Postgres databases, and a file locking protocol, that's real engineering.
It makes me think about how Git might change. Do you think we'll see native agent support in Git? Like git commit, agent id, or git lockfile.es?
I think we might see more first-class support for metadata. Right now, Git doesn't really care who wrote the code, just what the string in the author field says. But if Git could natively understand, this branch is an agentic exploration, it could handle merges differently. Maybe it uses an LLM to resolve conflicts instead of just looking at diffs.
Semantic merge. That's the dream. I see you renamed this variable, and the other guy used the old variable name. I'll just fix the references for you.
We're getting close. Tools like semantic diff already exist, but integrating them into the Git core would be a game changer for multi-agent workflows. Imagine a Git merge, strategy me. It wouldn't just look at line changes, it would understand that the intents of both branches is compatible even if the lines clash.
But isn't that dangerous? Giving an LLM the power to resolve conflicts without human oversight.
It's as dangerous as letting them write the code in the first place. That's why you have the tests. If the LLM resolved merge passes the test suite, is it wrong? In an agentic world, the definition of correct shifts from the human checked the diff to the system verified the behavior.
So, to summarize the disaster scenario, if you just open 3 terminal tabs and run Claude in all of them, you are basically playing Russian roulette with your source code. You'll get index.lock errors, you'll lose uncommitted work, and you'll end up with a mess of hallucinated code that doesn't compile.
It's the multi-agent merge nightmare. We talked about this in episode 1830, but it's becoming even more acute now. The solution is clear. Use worktrees for isolation. Use a lock server or orchestrator for coordination, and use a merge queue for validation.
And maybe, just maybe, don't let the agents commit directly to main yet. Keep them in their sandbox until the harness is mature enough to be the supervisor.
Definitely. The harness is the guardrail. Without it, you're just giving a chainsaw to a toddler who can think at 1 trillion operations per second.
A very polite toddler who says I have updated the files for you while the house is on fire.
I have refactored the structural supports of the living room. Please let me know if you need anything else.
Also, I deleted the kitchen because I didn't see anyone using it.
The lack of global context is the agent's biggest weakness. Git is a local tool. Agents are local actors. We need a global coordination layer to bridge that gap.
I'm thinking about the forgotten commit syndrome Daniel mentioned. You know, where an agent does a bunch of work, forgets to commit, and then the next agent comes in and thinks the workspace is clean. How do we solve that without making the Git history look like a disaster zone?
You use shadow commits. The harness should be doing a git commit agent checkpoint every time the agent stops typing for more than 5 seconds. These get squashed later, but they act as a save point in a video game. If the agent hallucinations lead it off a cliff, you can just rewind the disk state to the last shadow commit.
That's brilliant. It's like an autosave for your codebase. But what about the human side? If I come back to my repo after lunch and there are 400 checkpoint commits, I'm going to lose my mind.
That's why the harness has to be the one to clean up. It needs to rebase and squash those agentic explorations into a single, clean, human-readable commit once the task is verified. The agentic noise should never hit the permanent history.
Well, I think we thoroughly spooked anyone thinking about running parallel agents without a plan. But the upside is huge. If you get the orchestration right, your dev velocity doesn't just double, it scales with your compute budget.
It's a complete paradigm shift. We're moving from writing code to managing a fleet of code writers. And Git, the old reliable donkey of the dev world, is being forced to learn some new tricks.
Hey, don't call donkeys old reliable like it's a bad thing. We're very sturdy.
Oh, I know. I mean it as the highest compliment. Git isn't going anywhere. It's just getting a massive upgrade in terms of how we wrap it.
Alright, let's talk practical takeaways. If I'm a developer today and I want to start using multiple agents, what are the 3 things I need to do right now to avoid a disaster?
Number 1, learn Git worktrees. Don't just clone the repo 3 times. Use Git worktree add to create isolated environments. It keeps your main.git folder clean and allows your agents to work on separate branches without interference.
And it saves a ton of disk space if you're working on massive monorepos.
Takeaway number 2, implement a commit early, commit often policy for your agents. If your harness doesn't automatically commit after every successful tool execution, write a script that does. You want a trail of breadcrumbs. If an agent crashes or does something stupid, you want to be able to git reset to 30 seconds ago, not 3 hours ago.
That uncommitted work, failure mode is real. I've seen people lose entire days of work because a subagent decided to do a clean command that wasn't scoped correctly.
It's heartbreaking. And takeaway number 3, if you're building your own tools, look into the Model Context Protocol, or MCP. It's becoming the standard for how agents talk to tools and, eventually, to each other. If your agents can check in with an MCP server that manages file locks, you've basically solved the coordination problem.
Is MCP really ready for that? I thought it was more about fetching data.
It's evolving. People are already building locking servers as MCP resources. An agent says, I want to edit auth.ts, and the MCP server returns either a success token or a resource locked error. It forces the agent to handle the lock just like a database client would.
I like that. It's about building a better harness. Don't just blame the model for being stupid when it overwrites work. Blame the harness for letting it happen.
It's an engineering problem, not a magic problem. We have the primitives. Git gave them to us a decade ago. We just need to start using them properly for the agentic age.
Well, Herman, I think we've covered a lot of ground. From the creaking of Git's index lock to the future of semantic merging and agent fleets. It's a wild time to be a developer, or a sloth watching a donkey talk about code.
It really is. And big thanks to Daniel for the prompt. It's these kinds of meta-engineering topics that really show where the friction is in the industry right now.
Before we wrap up, we should probably thank the folks who make this possible. Thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes.
And a huge thank you to Modal for providing the GPU credits that power the generation of this show. If you haven't checked out Modal for your serverless GPU needs, you're missing out.
This has been My Weird Prompts. If you're enjoying these deep dives into the weird world of AI and engineering, do us a favor and leave a review on Apple Podcasts or Spotify. It actually makes a huge difference in helping other people find the show.
You can find all our past episodes, all 2003 of them now, at myweirdprompts.com. We've got the RSS feed there and links to all the platforms.
And if you have a weird prompt of your own, send it over to show@myweirdprompts.com. We love hearing what's on your mind, whether it's Git worktrees or the ethics of AI sloths.
Stay curious, keep building, and maybe, just maybe, check your worktrees before you hit enter.
Wise words, Herman. See ya.
See ya!
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We shake